Here is the next example based on the ideal transformer. Here he's asking us to find the current or power consumed by 6 ohm resistor. Okay, so the power consumed in this resistor, PL equal to I square times R. So as long as I find the current here, that should be good enough. Now here I can see 3 loops, so I'm going to assign 3 loop currents, I1 and I2 and I3. Okay, so before assigning, I see the given circuit is in time domain. You need to convert that into frequency domain. So when you convert this into frequency domain, here I have 12 cos 2t, so make sure that you convert that into RMS value, which is 12 over square root 2 at an angle of 0. So this is the V, and at the same time here you have capacitor in farad. You need to convert this into minus jXC, which is 1 over j omega c. Omega is 2, so which is 1 over j 2 times 1 over 20. So this is minus j 10 ohm. Okay, now once the circuit is in frequency domain, assign the loop currents. Okay, so here we have 5 unknowns. Those 5 unknowns are I1, I2, I3, V1 and V2. Okay, so you need to have at least 5 equations. Okay, so loop 1, apply KVL. So loop 1, apply KVL. Sometimes I might give this positive and negative signs, sometimes I don't. If I don't give you positive and negative signs, you have to assign them according to the dot convention. So in this case I gave you. So here 12 over square root 2, which is 8.48 volts. So minus 8.48 at an angle of 0 plus 2I1 plus V1 equal to 0. This is my first equation. Now the second equation is loop 2, apply KVL. Loop 2, apply KVL. So according to my I2 direction, plus minus minus plus, so basically 6I2, okay, I'm entering the positive and here I'm entering negative, minus V2 equal to 0. Okay, this is my second equation. Now loop 3, apply KVL. Loop 3, apply KVL. So according to loop 3, minus J10 I3, okay, plus V2 minus V1 equal to 0. This is my third equation. These are the 3 loop equations. Now based on the turns ratio or transformer ratio, we can find out another equation. So here the another equation is equation 4. I'm going to write it down here. V2 over V1 equal to 2 over 1. Now the important point is this positive or negative? Now assume that the current here is I1 minus I3. That current is entering the dot, so the dotted terminal must be positive. Do I have the positive there? No, negative. So V2 equal to minus 2I1. So V2 equal to minus 2 V1. Sorry, this is my fourth equation. Okay, I'm going to explain it one more time. I1 minus I3 is entering the dot, so the dotted terminal must be here. This must be positive, this must be negative. Okay, but I have opposite sign, so that's the reason I'm taking this as minus 2 V1. In the same way, now the current here supposed to leave this positive sign. The current supposed to leave this positive sign. So what current is going down? If I choose the current is going down, then I3 minus I2 is going down, or you can say I2 minus I3 is going up. Okay, but I can clearly see I3 is coming down, I2 is going up, so I can write down I3 minus I2 is going down. So this I3 minus I2 is going out of the positive terminal. So for that, we don't need to write negative. So I1 minus I3 over I3 minus I2 equal to 2 over 1. Okay, this is positive. So here I have 5 unknowns, 5 equations. The rest of it is solving those equations. So let me simplify this. So I have I1 minus I3 equal to 2I3 minus 2I2. So if I pull everything on the other side, I1 plus 2I2 minus 3I3 equal to 0. This is my fifth equation. Now what I'm going to do, I'm going to substitute equation 4 in equation 2 and equation 3. So that way I can eliminate V1 and V2. What I'm going to do, I'm going to substitute V2 equal to minus 2V1. So here I'm going to substitute minus 2V1. So 6I2 minus of minus plus 2V1 equal to 0. I'm going to label this as 6 equation. And the first equation I have minus, sorry, I need to substitute V2 in equation 3. So minus J10 I3 plus V2 is nothing but minus 2V1 minus V1 equal to 0. So I end up with minus J10 I3 plus minus 3V1 equal to 0. Let me take this as my seventh equation. Now equation 6 and 7, if I combine those two, I can eliminate V1. I mean, if I work on those two equations. So here I'm going to work on equation 6 and equation 7 to eliminate V1. So what I did, 6I2 plus 2V1 equal to 0. I multiplied that with coefficient of V1 in equation 7, which is 3. And equation 7, I multiplied coefficient of V1 in equation 6. So that way I can eliminate V1. So finally I end up with the equation with only two variables, I2 and I3. Now if I have another equation with these two variables, I can solve for those two and find I2 value. Our goal is finding I2. Now to eliminate, to get another equation, what I'm going to do, I'm going to work on equation 6 and equation 1. Okay, equation 6 and equation 1. If I work on those two, so that I can eliminate V1 in those two equations. So here I wrote it down, equation 6 and equation 1. Equation 1, I'm going to multiply equation 1 with 2. Okay, so this is 4I1 plus 2V1 equal to 16.96 at an angle of 0. That's my equation 1 after multiplying with 2. 6I2 plus 2V1 equal to 0. This is my equation 2. I'm subtracting these two. I will end up with 4I1 minus 6I2 equal to 16.96 at an angle of 0. This is my seventh equation. Now I need an equation with I2 and I3. Okay, here I have equation with I1 and I2. So let me work on equation 5. Okay, if you look at equation 5, I have I1 plus 2I2 minus 3I3 equal to 0. So I1 plus 2I2 minus 3I3 equal to 0. This is my fifth equation. What I'm going to do, I'm going to multiply this with 4. to eliminate I1. Okay, so this will be 4I1 plus 8I2 minus 12I3 equal to 0. I have equation 7 right there, which is 4I1 minus 6I2 equal to 16.92 at an angle of 0. Okay, I'm going to subtract these two. I will end up with minus 14I2 plus 12I3 equal to 16.92 at an angle of 0. Okay, this is my equation 8. Now I'm going to work with equation 8, and I already have equation 8. I should write this as equation, probably this is equation 9, and this is equation 10. Okay, now I'm going to work with equation 8 and 10. Okay, so equation 8, I have 18I2 minus J20I3. 18I2 minus J20I3 equal to 0. This is my equation 8. I believe that's the equation 8. 18I2 minus J20I3. Now equation 10, I have minus 14I2 plus 12I3 equal to 16.92 at an angle of 0. This is our 10th equation. Now to eliminate I3, what I'm going to do, simple way, just coefficients of I3. I'm going to multiply this with 12. I'm going to multiply this with 20. Okay, so after multiplying with 20, equation 10 is going to be minus 280 I2 plus 240 I3 equal to 338.4 at an angle of 0. Okay, multiplying with 12, equation 8, it's going to be 216 I2 minus J 240 I3 equal to 0. Can I subtract these two? Remember, this equation has J term, this doesn't have J term. You cannot subtract with those two numbers, or you cannot eliminate those two. So what I'm going to do, I'm going to multiply this with the J again. So J, so this will be J, so no more angle. So J is nothing but 90-degree angle, so you can add that later on. So now I can cancel these two. I'm adding basically. So minus J 64 I2 equal to J 338.4. Okay, now I2 equal to J get cancelled, 338.4 divided by 64. Okay, this value is negative though. So I2 equal to negative 5.28 amperes. So power consumed in the load, which is I2 square or L, okay, which is negative 5.28 whole square times the resistance is 6 ohms. So the power consumed in that 6 ohms is 167.74 watt. Okay, with this I'm done with this ideal transformer. In the next topic or next video, I'm going to talk about auto transformer. Thank you.